Hey everybody. Today we're using trig identities to simplify trigonometric expressions. There are lots of trig identities in the world, and many of them you can just kind of Google whenever you need them. However, there are some that are so common and useful and important that you really need to know them by heart for any trig or calculus class. In particular, you really need to memorize the reciprocal, quotient, and Pythagorean identities that I have listed here. They just come up all the time. Still worth knowing, but slightly less important, are these, the even-odd identities and cofunction identities. I'm going to use these in this video as well. Okay, let's do some problems. Problem 1, simplify cotangent theta plus sine theta over 1 plus cosine theta. I'm going to start by rewriting cotangent as cosine over sine using one of those quotient identities. This is a really common idea when you're simplifying trigonometric expressions. Rewriting everything in terms of sine and cosine and hoping that that clarifies the situation. Here I think that's the case. I think the next step is pretty clear. We need to get a common denominator and hope things start to cancel. The common denominator is sine theta times 1 plus cosine theta. I cross multiply to get the new numerator. Now I'm going to FOIL through the cosine theta times 1 plus cosine theta and immediately see a Pythagorean identity. Cosine squared theta plus sine squared theta is equal to 1. Now I have a common factor in the numerator and denominator. Cosine theta plus 1 and 1 plus cosine theta are the same, so those cancel. I'm left with 1 over sine theta, which can be rewritten using a reciprocal identity as cosecant theta. And that's about as simple as we could hope for this problem. Number 2, simplify cosine of t minus pi over 2 times the cosecant of t. When I see that t minus pi over 2 inside the cosine, I'm immediately thinking of a cofunction identity. However, those cofunction identities all have pi over 2 minus the angle rather than the angle minus pi over 2. So I got to deal with that somehow. Here, I'm going to factor out a negative sign from the t minus pi over 2 to make the inside of that parenthesis look more like it does in a cofunction identity. Now I can deal with that negative sign using an even-odd identity. Cosine of negative an angle is the same as cosine of the angle. So this can be simplified as cosine of pi over 2 minus t times the cosecant of t. Now that cofunction identity really does work. Cosine of pi over 2 minus t is just sine of t. Next, I'm going to use a reciprocal identity to rewrite cosecant of t as 1 over sine of t, and cancel to get the final answer, which is just 1. Problem 3. Expand and simplify secant x minus tangent x squared. There's any number of ways to do this problem. I'm going to start just by directly foiling it out. When I do that, I get secant squared x minus 2 secant x tangent x plus tangent squared x. Next, I'm going to choose to rewrite everything in terms of sine and cosine. Remember that secant is 1 over cosine, and tangent is sine over cosine, using the reciprocal and quotient identities respectively. Here I have a common denominator, so really I'm just combining the numerators to get 1 minus 2 sine x plus sine squared x. And of course that factors. That's 1 minus sine x quantity squared. Okay, so now I'm going to employ another common trick. I'm going to rewrite that cosine squared x in the denominator as 1 minus sine squared x. This is another form of the Pythagorean identity. Since sine squared plus cosine squared is 1, cosine squared of x is 1 minus sine squared of x. Now in the denominator there, I have a difference of squares. So I can factor that as 1 minus sine x times 1 plus sine x. That's good because I've got a common factor of 1 minus sine x that I can now cancel. I come out with 1 minus sine x over 1 plus sine x. That's about as simple as this expression can get.